Let's look at Codeforces round 852, problem C, Dora and search. Here we are given a permutation. A permutation is basically numbers from 1 to n arranged in any random order. We have to find a subsegment of the permutation in which the first and the last elements are neither the maximum or the minimum of the subsegment. And if such a subsegment does not exist, then we'll have to output -1. In this first example, let's try to understand what is happening here. The numbers 1, 2, 3, 4, 5, 6 and 7 are present. So this is a subsegment of n is equal to 7, right? So if you consider the entire array, then the first element is the min and the last element is the max. And we don't want such a scenario. The answer for this question is the subsegment from here to here, because the min of this subsegment is 2 and max is 6, and 2 and 6 are both present inside and not on the edges. That is why the answer is 2, 6, because this is the second index 2 and this is the sixth index, considering one based indexing system. Now the way we solve this question is we just try to see what condition is required so that the answer is possible. What is the condition? Condition is that last element is not equal to min or max, and the same is for first element. How do we achieve this? I've tried using a two-pointer technique. The reason why I used a two-pointer technique is because it's a permutation. So we know that the numbers are from 1 to n. So in the beginning, the minimum element is 1 and the maximum element is n. Let's look at the example. We start by taking the entire array. We take a left pointer and set it to the first element. We take a right pointer and set it to the last element. And if any of these, which are the extreme values, are either min or max, then it's not a valid answer. So if the first element is either min or max, we move rightwards and we update the minimum. Since 1 is outside of the scope now, we no longer consider 1 to be the minimum. We can store a min and max variables. Originally, the min will be 1 and the max will be n, which is 7 in this case. But as soon as we move the pointer from first index to second index, our minimum becomes 2. Why? Because 1 is no longer under consideration. Similarly, the last element is 7, which is a max. So we move it leftwards and we cancel max to be 6 right now. So over here, this element is neither 2 or 6. This element is neither 2 or 6. So this is a valid test case. We just have to code this up. Let's look at the code now. Let's look at my submission which got accepted. It's a very simple solution. We make an array of size n and we input all the elements. Then we check if n is less than 4 or not. If n is less than 4, then we print -1 because there is no answer. The reason for this is, for a min and a max to be not the last elements, there has to be some element after the min and after the max. So there is 1, 2, 3, 4 elements at least. Then we can fill elements over here, here or here. But these are optional. But this is compulsory. So minimum size for making a valid array is 4. So for the subsegment to be 4, the total length of the array also has to be at least 4. Hence this condition. So if n is less than 4, then we print no solution. After that, we take the L and R, which is the left and right pointers, and set them to 0 and n-1, and the min and max to be 1 and n. Now, while L is less than R, if ARR of L is the min, then we increase the L and increase the min. And if it is the max, then we decrease the max but increase the L. In these cases, we are going towards the right side. Same thing, if the right side element is equal to the min or max, we adjust the values accordingly. And if such a case comes in which there is no extreme values at the extreme ends, then we print that L plus 1 and R plus 1 as the limits of that subsegment, and we set the boolean flag which indicates we found the value or not to be true. Now if we didn't find the value, we'll print -1. So that was it. It's a pretty simple question in my opinion. 2-pointer approach. Problem C. Thanks for watching.